All right, so continuing on, here I'm going to let u equal this 6x. So u equaling 6x, taking the derivative, du will give you 6dx. So to substitute in for the dx, I'm going to multiply both sides by 1/6. So this turns into cosecant squared of u times 1/6 du. I like to take the time to move the 1/6 outside and think about what is the antiderivative of cosecant squared. You know that's negative cotangent of u, and then you put the u back in. All right, so you're noticing all of these u substitutions are just a number times x. So this here, thinking about it, x over 4 is the number 1/4 times x. So to take the derivative, we don't need quotient rule, it's just 1/4 dx. So I need to replace for dx, I'm going to multiply both sides by 4. So I get integral of cosecant squared of u times 4 du. Again, I'm going to pull the number on the outside. So I see that's going to be negative 4 cotangent of u plus c. And then put the x's back in. So just looking at this, here I had the initial angle of 6x, so I got a 1/6 on the outside. The initial inside angle was 1/4 times x, I got a 4 on the outside. So we're going to be developing a pattern in this next page here. But let's do one last problem. So here if I let u equal 5x, this du is 5dx, so I see that I don't have a 5, so I'm just going to be solving for dx. So I have cosecant of u, cotangent of u, times a 1/5 du. So I'm going to pull the 1/5 out on the outside, thinking about what is the antiderivative of cosecant cotangent, and I know that that's negative cosecant of u, and then I put the x's back in. All right, so moving on to the pattern that I've established on the next page. My page is frozen. All right, so if you're looking at the next page here, you can see the pattern that I'm going to call La Jolla theorem. And I want you to memorize these so that you can see that, let's see if I can get the page to move now. Oh, there we go. Okay. So, not this page, sorry, not the next page. Anyway, one more little work with the e's, with this easy u substitution. And on the next page, I have the list of patterns I want you to memorize. So here I want to let u equal 3x. du is 3dx, so I have 1/3 du is dx. So this turns into e to the u times 1/3 du. So pull the 1/3 outside. Integral of e to the u is just e to the u plus c. So then I put the x's back in, and I have the answer. Here I'm going to let u equal negative x. So du is negative dx. So put the negative on the other side. So I get e to the u and then negative du. So again, pull those numbers on the outside. So e to the u plus c, and then put the x's back in. One last one, let u equal x over 4. So du, remember this is the same thing as just saying 1/4 times x. So the derivative is 1/4 dx. So 4 du is dx. So I want to replace the dx with 4 du. And then I have e to the u. So you remember integral of e to the u is just e to the u. So then I put the x's back in plus c. All right. So I want to make sure that you have a healthy fear of integrals. They are harder. So this one here, there's no u substitution. This one you would have to multiply out. So what I mean by that is you would have to do 6x plus 2x to the 4th and then integrate it term by term. This one here, you would have to multiply out. So there's not, this U substitution does not work every single time. So be careful you're looking at it. And this one here, we cannot do for now. So be careful that you don't ever make that bad math mistake. All right, these are the patterns, and all of these, if you look back in the examples we did earlier, this is the U substitution. So I'm going to refer to this as La Jolla theorem. I'm going to want you to understand and have these patterns memorized for the antiderivative, and I want to make sure that you see those different for the derivatives. This is chain rule, so make sure you know the difference.